Hey everyone. So thank you for coming to this talk today. Rishi and I are really excited to talk to you all about some really cool technology that we're bringing to Avalanche and the go-to-market and business strategy behind what we're building, and how Avalanche's technology really empowers these novel solutions for solving cold start problems in bootstrapping blockchain technology, as well as being a very strong crucible for innovation. So we're Movemnt. A little bit about us: we're both Vandy dropouts. We dropped out to build in the Aptos ecosystem because we were very bullish on the Move language. And in case you don't know about Move, it was this project that was designed by Facebook's Libra team in order to solve a lot of the vulnerabilities and friction points of the Solidity programming language, as well as be a blockchain execution layer that big tech companies feel comfortable building on top of. So the Libra project was unable to be brought to market due to issues with compliance and regulation and stepping a bit on the toes of the US government. And the teams broke up into these two novel blockchains, Aptos and Sui. So what we are doing here is bringing Move to market in a Web3 native way, lowering the barrier to entry, and making it more accessible. So really excited to talk to y'all. So what our mission here is to make Move decoupled from any given L1, be able to be plugged into different distributed networks, and make it so that builders are able to build novel applications, infrastructure, and blockchains without necessarily being bound to a single chain. And what's really powerful about the Avalanche network is that its subnets enable us to make Move modular. So what that means is that within different blockchain stacks, we are able to abstract away like data availability, settlement. So what that looks like in practice is that for different applications like games, we're able to actually boost their TPS. So not only through the Move language natively, but also being able to push additional tech stacks geared specifically for those projects. So looking at Move as a language, it has unparalleled security. So a good way to think about this is if you look at Solidity. Smart contracts are these abstract lines of code, even tokens themselves. It's not a very intuitive development process, and it's difficult to read. So what that looks like in practice is that as Solidity applications scale and become more complex, the number of attack angles increases exponentially as they become more complicated. But with Move being an object-oriented programming language, what's really powerful about it is that within modules, you are able to define where assets can move to and from, as well as who has the authority to move those assets from one place to another. So you can think of it as being able to build in guardrails to your smart contracts, which not only makes a more intuitive development experience, but as applications become more complex, the vulnerabilities scale a bit more logarithmically than exponentially, as we see with Solidity. Looking back at the last cycle in 2022, we saw around $3.6 billion in smart contract hacks, which was more than ever. And if we were going to see mass adoption, we need to address this problem. And Move being able to bring intrinsic security into the market is a very powerful value add for onboarding the next generation of retail users and Web3 investors. So this is a little bit more of a technical comparison between Move and Solidity. So as you can see, Move was designed to solve a lot of the friction points that builders have had with Solidity. And what's very interesting to me is that Solidity and even the Ethereum network itself, it was such a great leap forward in terms of technological innovation that it is impossible to get everything right the first try. And so ETH and Solidity, like Bitcoin, they were pushed with known flaws and limitations, with the expectation of builders iterating on top of them to create solutions for the problems which would inevitably pop up with taking such a large leap forward. And Move was developed to solve for a lot of these. So if you compare it to other languages like Rust as well, this is a technical breakdown of some of the security features with the Move language. So for example, before a transaction occurs, type and memory safety is checked. So a lot of vulnerabilities that we've seen, for example, like the DAO attack in 2016, big reentrancy vulnerability within Solidity was exploited, and funds were just consistently stolen from this fault. That is just not possible with the Move language. It has a lot of other baked-in security features as well. So it's a very powerful language to build with. It's more intuitive from a development experience and much more secure than existing languages on market. So as Movemnt, we are beginning by launching a layer 1 on the Avalanche network called Mocha. So it's extremely high throughput. We've done some tests with regard to TPS, and we were able to hit 50,000 TPS before even implementing parallel processing, which is another very powerful feature of the Move language. So we're backed by a lot of awesome partners, particularly from the Avalanche ecosystem. What's powerful about Movemnt is that using subnets, we're able to scale horizontally by supporting multiple virtual machines in their respective ecosystems. So down the road, we're becoming a sort of melting pot of different VMs and ecosystems, all of which being based in Avalanche. So why Avalanche? We talked with every blockchain out there for bringing Move to market. And what we found is that Avalanche is light years ahead of other chains in terms of their cross-VM interoperability technology. So looking at chains like Binance and Polygon, their side chains and supernets respectively don't have the technological infrastructure to support cross-VM interoperable solutions. That is, you are able to launch side chains, but you're not able to do so in custom VMs and being interoperable with the primary network. So what's really powerful about Avalanche is with Avalanche Go, you're able to create communication channels between custom virtual machines to compile the bytecodes down into something that Avalanche Consensus is able to interpret. And with subnets, every subnet validator is also validating the primary chain. And so you're able to have consensus through that mechanism. One thing that stuck out about Cosmos as a second place contender is that although it has inter-blockchain communication for the support of custom virtual machines and being able to have communication between those networks, Cosmos does not share common users and common liquidity. So the reason that we are bringing Move to Avalanche is that it's facing a very difficult cold start problem. Every novel L1 faces a harder time bootstrapping their users, liquidity, and projects as the previous. Because L1s, their market, go-to-market has been creating moats around their users and liquidity, which is something that we really see with Ethereum, for example, that it's kind of problematic that if you are not building an EVM, then you are cutting yourself off from the biggest pool of users and liquidity in the blockchain space. And so in a way, we're kind of entrenched in this decade-old technology, which is stifling innovation. So what's really powerful about subnets specifically is that with connectivity with the primary chain and with other subnets, you're able to much more efficiently onboard your initial users and your initial projects, as well as liquidity, because you have full backwards compatibility and connectivity with those chains. So one powerful solution that we were able to bring with this is liquidity. So we're partnered with Benki, and Love that team. So the way that this works essentially is that Move applications on the Mocha network are able to make requests to Binky and natively tap into their very large swath of liquidity, which is actually more than the entire Aptos ecosystem, multiple times of that. So applications that are building in the Move language that traditionally struggle to get past a few $100,000 in TVL are now able to access millions of liquidity right out of the box. We're also able to create Move as a service. This is the framework which we have plugged into the Avalanche network, such that we're able to create L1s, distinct layer 1s, based in Move that are communicable with the primary chain, as well as create roll-up solutions. And one very powerful solution we're able to bring to market with this EVM integration solution is creating sidechains and roll-ups specifically for distinct applications. So for example, games, they oftentimes need their own execution environment because of the large number of transactions that they're processing. One of the original use cases for subnets was that Krabata was taking up so much of transaction volume that it was slowing down the chain and leading to more expensive gas. So once they got their own layer 1 solution for their application, the primary chain was able to be faster, more efficient, less gas, and Krabata also saw cuts in times. So the architecture that we are bringing with Mocha is that we have horizontally scalable execution layers. So we're starting off with an Aptos Move VM so that we're able to support the builders from the Aptos ecosystem, help them get plugged into more users, more liquidity. But on our roadmap shortly after, we'll be launching a SWE Move virtual machine as well, supporting that ecosystem. And we're also building a ZK Move virtual machine as well. All of this connects with the Avalanche consensus and settlement layers, and will be one of the first chains that is partnered with EigenDA to push their data availability layer as well. And if you are a builder on Mocha, you are able to choose what virtual machine you're building on. You're able to create your own custom blockchain stack for your application. And then above all else, you are connected to our users, our liquidity, and all of our projects out of the box. So some really cool technology that we're pushing forward is we've made a lot of Avalanche's tech that enables cross-VM interoperability, VM agnostic. So originally this was working for Solidity and Rust, which are two subnets, or rather two languages that have been supported by the Avalanche network. But now it's completely VM agnostic, so we're able to support Move applications, and we're able to support Solana VM, you name it. We're also bringing parallel processing to Avalanche. This is a really powerful feature of the Move language, which enables better efficiency, both for DeFi and for gaming. So with games pushing so many transactions forward, it's huge for users to not get encumbered by having to wait for other users' transactions to process, be verified, and settled before reaching to their own. We're also building equivalents of Truffle, Hardhat, and Ganache for the Move language. So one major pain point of Move is that as a novel language, there's not a lot of tooling for it. So it's difficult to pick up. I mean, the way that people built in Aptos and SWE was that we had this huge Telegram chat. That was the only way that people were debugging their code and learning how to build novel features with the Move language. So we'll be supporting builders on that front too. So we're also going to be scaling the Move ecosystem. The way that we see it is that a rising tide raises all ships. So this is starting with Move, but down the road we'll be supporting more applications such as games, such as NFT projects as well, who will be able to overcome cold start problems for launching their solutions by having a diverse base of users across different networks and different ecosystems who will be able to use their products out of the box. The way that we see this is that we're decoupling innovation from inaccessibility. So this is another look at parallel processing. So we're able to theoretically reach 160,000 TPS, similar to Aptos, but with a sidechain subnet infrastructure, we're actually able to launch subnets within subnets. So let's say that you are a game and you're reaching these TPS boundaries. We're able to launch novel instances of blockchains to further offboard transactions too. So theoretically, we're able to reach infinite TPS, but more likely will be something around the ballpark of 50K to 160,000. So in addition to having higher throughput and bring novel parallel processing to Avalanche, we're also bringing intuitive developer tools to support our builders, such as documentation, such as integrations, like an easy CLI, as well as making it simple for Move builders to access interoperability and communicate back with the Avalanche primary chain. So a few really cool use cases. So in terms of DeFi, you're going to see better security and you're going to see higher throughput for applications, which is really going to boost consumer confidence in apps. As we mentioned, there was over $3 billion stolen in hacker attacks last year, and that's at the forefront of every user's mind. So using Move solutions, you're able to stand apart from all of the other DeFi applications in the market with much better security. From the gaming front, parallel processing is able to significantly boost TPS and lower the time that users will be spending waiting for transactions to process, as well as remove a lot of bottlenecks that we see within games. So from the NFT side, one really cool innovation that SweMove has brought to market is dynamic NFTs. So what dynamic NFTs are, different attributes of the NFT are able to upgrade based on smart contracts. So that can be something like when you stake tokens or an NFT for a certain period of time, the NFT's aspects upgrade. One really cool use case is within games. Let's say you have a first-person shooter game. You are able to have your weapon upgrade in terms of cosmetics by completing certain challenges. So the way that we see this is that NFTs have traditionally been used to prove that someone is a part of a community. Dynamic NFTs let you prove where you stand within that community. And it also allows for much more powerful derivatives for games. So it really incentivizes people now to be grinding out, let's say, weapon skins or grinding out challenges in order for their character or their items in game to get cooler as well. So short term, what we're doing is addressing the cold start problem that we're seeing with the Move language, because if technology is inaccessible, it's unadoptable. Move has the potential to revolutionize smart contract security and open the door to new innovations within Web3. But the issue is that if users have to leave their established networks who have had years to build moats around their users and liquidity for chains that are underdeveloped and infantile, financially, users and devs are disincentivized to learn the Move language. And so by making technology more accessible and by kind of being like Amazon, delivering it to the front door of users and builders where they are today and lowering the overhead to build with novel, innovative technology, as well as decoupling it from the inaccessibility that we see today, we believe that we'll be able to usher in a new era of Web3 development. So we plan to onboard the next generation of Web3 users and builders who will be looking for innovative technology, who will be looking for security above all else. For the users, we're going to support them with Move security and with Avalanche's very powerful consensus mechanisms. For existing projects in Move, we're going to support them with getting paired with more users and liquidity. For projects in the Avalanche ecosystem, we make Move natively accessible to them. So for example, if you're a gaming application, we can spin up a custom blockchain for you in which you're able to not only offboard transactions to in order to help boost TPS for your network, but that can be done with parallel processing as well. For builders, we're going to be creating a large swath of comprehensive documentation to make it easier to pick up the Move language, to make it easier to build Move applications, and to bring it to market with tooling. So in terms of our gas fees, we're able to keep it incredibly cheap, looking at 26 to 27 gwei, which is going to be like 1,000th of a cent about. And we're able to keep gas cheap, and with subnets, you're able to create custom gas rules as well. So for gaming applications, for example, ones that need very high throughput, we're able to push this number even lower. In terms of our token, it's absolutely revolutionary. It's nothing like any token that has ever been built before, because all of the different respective ecosystems that we will be supporting will be using our Movemnt token. So what we see is that its value is accruing from multiple directions, but is also hedged against multiple ecosystems, which brings a lot of security to our users who won't have to worry about, if an L1 ever falls out of favor, naturally its token is going to greatly diminish by being hedged across multiple ecosystems. And every time that we support a new virtual machine, bringing on an entirely new set of users and projects driving demand for the token, we're confident that we will be able to do our investors well. So in terms of a roadmap, we have already built out a Move virtual machine prototype, as well as built our Mocha subnet. We currently have a DEX that is running on our DevNet, which I'm really excited to be sharing a demo with you all shortly. So coming up next will be our incentivized testnet, where we're going to be supporting Move builders who will be coming over from Aptos and Suite ecosystems over to Avalanche to help get them connected to our network, as well as creating a lot more documentation and SDKs for our network. And then down the road, with our mainnet live towards the end of this year, early next year, we'll be able to expand the Move umbrella as well as the Avalanche consensus into more ecosystems, such as Cosmos. So the bigger picture that we're building here is a melting pot of virtual machines. So we're bringing Aptos and Suite together, making them natively interoperable and fully communicable with the broader Avalanche network. But we are also creating this meta network in which we are supporting multiple virtual machines and multiple ecosystems, such that we're solving a huge pain point that we've experienced in Web3, in that when you choose what tech stack you are building with, you often get siloed into a certain chain and fully locked into that. That is, if you're building with the Move language right now, there's only a few places that you can go. And for all of the respective downsides of those chains, they're non-negotiable. Whereas with building a network of networks, we are able to hedge associated downsides, kind of abstract away what is good about technology and plug it into unique environments such that now there's a lot more choices for builders, and that they can just focus on building the technology that they are passionate about without having to worry about inherent limitations with go-to-markets for what they are building. So we're really excited to build a liquidity hub of multiple ecosystems, as well as open the door to native communication between different virtual machines, not having to worry about bridges and the likes, which we believe is going to lower the overhead for collaboration between different virtual machines, as well as different networks, and be a place in which builders are able to congregate to be able to better support one another. So really excited to show you all our demo. It's here. Cool. So this is a demonstration of our DEX, which we've built on the Movemnt network doing a cross-token swap.
My name is Jason, and I'm excited to present to you all the first DEX deployed on the Movemnt subnet. When you first access the dApp, you'll be asked to connect your wallet, and from there you'll need to add the Movemnt subnet as a custom network on your wallet using the RPC URL provided on this page. As I go ahead now and swap over to the Movemnt subnet, I'll be able to access the swap page, where you can trade the Movemnt token with a number of test tokens we've also deployed on the subnet. So let's say you want to swap 5 Movemnt tokens for AVAX. The dApp will calculate the output amount, and you can go ahead now, submit the transaction, and as it's confirmed, you'll see your balances change as well as the pool reserves change. From the pools page, you'll be able to add liquidity as well as remove liquidity, and also register new pools as new tokens are added. So let's now add liquidity to the pool that we just traded on. Let's say we want to add 5 AVAX tokens. It'll calculate the correct amount of movement tokens. Go ahead and add the liquidity. As you'll see, you'll be returned this LP token, which we can later redeem on the remove liquidity page for the corresponding amount of tokens that we added. So let's go ahead now and say we're going to remove 300 LP tokens. It'll calculate the correct output amounts, as well as show you the pool reserves of the total amount of liquidity in each pool. So as we go ahead here, you'll see we get back the tokens that we added, confirm the transaction, goes through, and now we have the liquidity back. In addition, we have a faucet for all of the test tokens where you can get an arbitrary amount of tokens for testing. And additionally, we have the Movemnt faucet where you can get test gas tokens as well.
So that was a quick demonstration of an application running on our subnet. I'd love to open up the floor to y'all for any questions that you have regarding what we were building.
Thanks for the presentation. Really interesting. I just not super clear on the difference between Mocha, which I think is a subnet, an Avalanche subnet, and the Movemnt network. And related, it sounds like you're trying to solve the problem of liquidity fragmentation, as you said. You know, people have to choose which chain. Do they not just end up having to choose like the Movemnt network now instead? And I hope that you guys bridge across to all these other networks. Just trying to understand those two pieces.
For sure. Thank you for the really insightful question. So for the first aspect of the difference between the Movemnt framework and Mocha, Movemnt is what enables the deployment of custom virtual machine solutions that are fully interoperable and communicable with the primary networks of different blockchains. And so that is how we are bringing Move to Avalanche, which the L1 subnet which we were building is Mocha. So that is the first product that is powered by the Movemnt framework. And in terms of your second question about how we solve fragmented liquidity and if that could, in the future, kind of force people to launch on the Movemnt network and run into the same problems, we see this as a complementary solution. So they can very easily launch on any given chain as well as on the Mocha network. So what that looks like is the implementation of a very small module. Probably takes like 5 to 15 minutes, a few lines of code, and you're able to immediately launch on the Mocha network as well. So we see this as complementary in that instead of having to just be on one network, now they can be on multiple. And as we expand, for example, into supporting Cosmos ecosystems, now they can launch on 3 different blockchains in theory by using the Movemnt framework and the Mocha network. Yeah.
Can you talk a little bit about the interchain communication? Like how are you, if these different networks have different consensus algorithms, different validator sets, how are you actually achieving this sort of pure inter-blockchain communication without something like IBC?
Yeah, for sure. Thank you for the really insightful question as well. So in terms of interchain communication, we're working with a partner right now for the Cosmos ecosystem specifically, which enables cross-communication between Cosmos and the Avalanche network. So I want to give a real quick shout out to the Landslide team and Nathan, who have built absolutely incredible technology in that respect. Yeah, Landslide.
So in terms of technology, you're building a single subnet and you're trying to deploy multiple chains within that subnet, each running their own VM.
Exactly. Yeah, what's really powerful about subnets is that you're able to launch subnets within subnets. So the Mocha network will consist of multiple different virtual machines, but even within those VMs, for example, in our app.dos move VM. If you are building an application, we can launch an app.dos move VM subnet for our app.dos move VM subnet. So for specific applications.
And communication between those chains, it's based on warp messaging, or?
Yeah, it's based on warp messaging. So there's full communication from subnet to subnet, as well as with the primary network.
Thanks.
Mm-hmm. Thank you.
Yeah, thank you for the presentation. So you talked about the Mocha network, and as a builder, can I also like spin up my own subnet using the Movemnt?
Yeah, absolutely. So what the Mocha network enables is that you can not only spin up your own subnet, picking what execution environment, so what virtual machine you want that subnet to be built with, but we also make it very easy to customize the other layers within your chain. So for example, your settlement layer, your data availability layer, yeah. So at the end of the day, what we're trying to do here is make cutting-edge technology accessible and easy to build with. So right now, there's a lot of friction in spinning up your own blockchain. There's a lot of friction in integrating different modular stacks. And when you do so, it's very hard to onboard liquidity into those distinct environments. So not only do we make it easy for builders to create their own blockchain solutions, but then also being paired not just with the users and liquidity of the Mocha network, but also the broader Avalanche network. Cool. Well, I think that about does it on time. Thank you all for coming to this presentation, and Rishi and I will be around to answer any further questions, and always happy to jam a bit on Move and subnets. So thank you.